2 hours? No, it's red.
Is it red? Oh, okay. Okay, today we're going to start off our math lesson with a review. So, we're going to review fractions from what we learned yesterday. So when we have a fraction, this is a number, let's say 4, and this is a number, let's say 5. What is this top place called in a fraction? Margie.
A numerator.
That is correct. That is our numerator. That is correct. The top place or top number in a fraction is the numerator. What is this bottom number called in the fraction?
Denominator.
That is correct. The denominator. Yep. Our bottom number is the denominator and the top number is the numerator. So when we're adding like fractions, we have the same denominator, right? So if I have a third of a bag of apples and Margie has a third of a bag of apples, together, how many apples would we have? Like our bag of apples, a fraction of a bag of apples. A third and a third. If we add these together, remember from yesterday?
2/3.
2/3, that's right, because the denominator stays the same when we add like fractions, right? Because their denominators are the same. So like 1/3, here I'll show you, 1/3 plus 1/3 equals 2/3, because the denominators stay the same always, right? It's the same for subtraction. Remember from yesterday, guys? Okay. Alrighty. So today we are going to go on to the next step of our lesson and learn about adding fractions with unlike denominators. Yes. So when we add fractions with like denominators, or they have the same denominator, we leave the denominator the same because the fractions are representing the same whole. Okay. So we have the same number of parts. So when I had a third of a bag of apples and Margie had a third of a bag of apples, we both had a bag of apples that represented 3. Does that make sense? There's 3 parts to that whole. So, yeah. Okay. So, the denominator refers to what the fraction is of. So if I have 5/6 of a pizza, let me show you with the diagram. So if I have a pizza, and it's broken into 6 pieces, and I have 5 of those pieces, all that is mine. The whole pizza is made up of 6 pieces because the pizza is broken into 6 parts. And I have 5 of those. So the whole is 6. So the denominator represents what the fraction is of. Okay. Alright, so when adding or subtracting fractions with unlike denominators, each fraction is representing a different whole. So if I have a third of a pizza and Ben has 3/5 of a pizza, our pizzas are representing different wholes. I have this much of a pizza. Hold on, I'll show you. And Ben. Okay, and he has. See how they're representing different wholes? I have a third of a pizza. I only have 3 pieces, like, total of my pizza. And he has 3/5. Like, they're totally different numbers. Totally different, because their denominator is not the same. So if we're going to add them together, we need our denominators to be the same. We need our fractions to be equivalent, or like, and be in like terms. Okay, so I'm going to demonstrate to you how we're going to do this. Does anyone have any ideas how we might add 2 fractions together that have unlike denominators?
Find numbers if they both go into, and then wait for the denominators to say.
Yeah, we have to. Yeah, the first step is definitely to make the denominators the same. So I'm going to draw you a diagram of mine and Ben's pizzas. 3, 4, 5. Okay, so I have a third of a pizza. This is my pizza. He has 3/5. 2, 3. Okay, so that's how much pizza I have. That's how much pizza he has. So we want the same number of parts in our fraction, in our denominator, right? Because we want their denominators to be the same when we add them. So for this 1/3 and this 3/5, we want them to the denominators to be the same number. So we want the same number of pieces in our pizza. So if this is 1/3, how do you think I can get the same number of pieces in my 1/3 diagram as in my 3/5 diagram? Is there a way that I can break these 3 parts up so that they will have the same number of these if I break this up too? What if I took my 3 parts and broke them up into 5 pieces each? How many pieces would I have then? Here, I'll show you. Okay, here's a third. I'm going to break it up into 5 pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's our original 3. There's our original 3, and there's our new ones. So, count that for me, Cheyenne, and tell me how many pieces do I have?
15.
That's right, we have 15 pieces. Alright, where did I get the 5 from? How about this? If I tell you, since this is a third and this is 3/5,
That's backwards 3.
and this is 3/5. Okay, so then I looked at this denominator to tell me how many pieces I should break my thirds up into. So when we're trying to find like denominators using a diagram, look at the other fraction's denominator, and that'll tell us how many pieces we need to break up each of our parts into. Does that make sense, everyone? So if I broke 1/3 up into pieces of 5, each of my thirds are broken into pieces of 5, how many pieces do I need to break my 3/5 into? If I looked at this denominator, would I look at this denominator?
The top one?
Yeah, so I'd look at the 3, right?
Yeah.
Yeah. So how many pieces am I going to break each of my fifths into?
3.
3, that's right. So, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So you see that? Count that for me, Erica, and tell me, how many pieces do I have there now?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
15. So now do each of my fractions now have the, like each of our pizzas have the same amount of pieces? Yes, that's right. Okay, so they both have 15 pieces now. Okay, so let's look back at my 1/3 drawing. So, how many, here I'm going to shade this better so you all can see it. Okay, so this is 1/3. Remember, here's our 3 original pieces. 1, 2, 3. And I have one of those chunks colored. Now, out of our 15, how many do I have colored, Marty?
5.
5, that's right. So, our new fraction would be 5/15, right? Because we have 5 of the 15 parts colored in, because that's how much pizza I have. So, does that mean that 1/3 and 5/15 are the same then? See how this is 1/3, 1, 2, 3 of our original, right? And I had a third of a pizza. And then when we broke it up into 15 pieces, I didn't gain any more pizza. I just broke my pizza up into more smaller parts, right? So I have 5 pieces out of 15 total. So you see how 1/3 and 5/15 are the same number? Does that make sense to everybody? Okay, so if we look down here at 3/5, how many did I have originally? I had 1, 2, 3 out of 4, 5. So I had 3 out of 5. Ben did, actually. Ben had 3 out of 5. 3/5. So when we broke his pizza up into 15 parts, count for me how many he has now.
1, 2, 3, 4, 5, 6, 7, 8, 9.
That's right. So he went from 3/5 to 9/15. Because he didn't gain any pizza when he broke his pizza up. He just got more pieces, but they were smaller. So they're still the same amount. Because 3/5 is the same or equivalent to 9/15. Because there's 15 pieces here, and he has 9 colored. Or if we looked at it as 3/5, he has 3 of the 5 pieces. Does that make sense to everyone about equivalent fractions? Okay. I'm going to move on to another example. Oh, and then if we're adding these together, so if we add, since they now have the same denominator, 5/15 and 9/15, remember that's the number one step we must do when we're adding fractions with unlike denominators, is to get them to have the same denominator. So now we just can add up our shaded parts, or just add in like a normal fraction that we did yesterday with like denominators. So 5 plus 9 over 15 equals, what's 5 plus 9? 14, so it's 14/15. That's how much pizza Ben and I have together. Okay, woohoo! Alright, let's move on to another example. And I want you guys to use your scratch paper here, and I want you to follow through with it, with me, I guess. Okay, so we are going to look up